So now we'll discuss the page replacement policy, LRU, least recently used. Okay, so in LRU we will replace the least recently used page in the past. Okay, with the example it will be, the definition will be more clear. So here for the frame numbers 4, first we'll try to see how it will go. Okay. So frame number 1, frame number 2, frame number 3, frame number 4. When the frame numbers are 4, I'll see how many page fault will be there. For the string 7 0 1 2 0 3 0 4 2 3 0 3, then 2 1 2 0 1 7 0 1. Okay, these are the strings. Here 3 for 0, for 4, for 2, 3 0 3 2 1 2 0 1 7 0. Okay, so here at the beginning the requested page by the CPU is 7. Okay, whether 7 is there in their main memory? No, so it will be a page fault. I'll write here 7. Then the next requested page is 0, whether it is there in the main memory? No, so 7 0. Then next requested page is 1, again it is not there in the main memory, so it is a page fault, 7 0 1. Next is 2, again it is a page fault, 7 0 1 2. Then next requested page is 0, whether it is there in the main memory? Yes, it is there in the main memory, there is no page fault, I'll write as it is. Then 3, so whether it is there in the main memory? No, it is not there, so it will be a page fault. Now which one I'll replace? I'll replace the least recently used page in the past. Okay, so if I say out of 2, 1 0 and 7, 0 is the most recently one used one. Okay, so I'll not replace this one. Then the next use is 2, so I'll not replace this one as well. Then we'll see 1 is the most recently used, like it is not the least recently used one. Okay, so 1 also I'll not replace. Again 0 was used, obviously 0 we are not going to replace. Then the least recently used is the 7 page number 7, so that's why I'll replace here 7 0 1 2. We'll write like this. Then the next requested page is 0, which is again there in the main memory, so I'll just write like this, there is no page fault. Then 4, whether it is there in the main memory? No, so there will be a page fault. Now which one I'll replace? We'll again see, we'll see here through this direction only. Okay, 0 is recently used, I'll not replace. 3 also used, no. 0 2, okay, then 1. Okay, so among 2 1 0 and 3, 1 is the one which was used the least least in the past. Okay, so it is least recently used, whereas 0 is the most recently used. Okay, so I'll replace 1 with 4, 2 here, 0 here, 3 here. Okay, then next request is 2. Okay, it is there in the main memory, so I'll not replace. Next is 3, it is also there in the main memory, I'll not replace. 0, it is there in the main memory, so I'll not replace. Then again 3, it is there in the main memory, I'll not replace. 3, then is 2, it's there in the main memory, I'll not replace. 0, 3, then 1. So whether it is there in the main memory, no, so it's a pace fault. Which one I'll replace? And again I'll see in this direction only. 2 was recently used, I'll not replace. 3 also recently used, I'll not replace. Then 0 was used, I'll not replace. Then the 4 is that pace which is least recently used. Okay, so I'll replace here 4. Then 2 again. Okay, this one is 2, sorry. 2 is there in the main memory, there is no pace fault. Then 0, it's there in the main memory, there is no pace fault. 1, it is there in the main memory, there is no pace fault. 7, it is not there in the main memory, there is a pace fault. Which one I'll use? Again I'll see in this left direction. 1 is just recently used, 0 also recently used, 2 also recently used. So 1, 0, 2, 3 is the least recently used one. Okay, so I'll replace here 3, 0, 1, 2. Okay, then the next request by the CPU is 0, it is there in the main memory. Sorry, this is only 1, so I'll not replace, there is no pace fault as well. 1 is also there in the main memory, so I'll not replace. Okay, no pace fault. So number of pace fault is 1, 2, 3, 4, 5, 6 star, 7 star, 8 star. So total number of pace fault here is 8. Okay, similarly I will now change the number of frames. Okay, I'll use number of frame 3 and then see what happens, how many pace fault I may encounter. I'll see. Okay, so for 3 number of frames, let me redraw this table. Okay, so here 2, 3, 4, 5, 6, 7. Frame number 1, frame number 2, frame number 3. The requests are 701, 203, then 042, then 303. After that 2 is there, 2, 303, 212, then 01701. These are the requests. So here the first request 7, which is not there in the main memory, pace fault. Second, pace fault, not there in the main memory, 701. Third, also pace fault. Fourth will again be pace fault, right? And which one I'll replace? The least recently used in the past, that one, that pace I'll replace. So 1 has just been used, so 1 is the most recently used one, then 0, then 7. So the least recently used is 7. Okay, so 2 I'll replace with 7. Then 0, it's there in the main memory, no pace fault. 3 again I have to replace, so 0 most recently used, 2 also. 1 is the one which is the least recently used, I'll replace here, it is a pace fault. 0, it is there in the main memory, no pace fault. 4 is not there in the main memory, I'll replace, I can replace 0 most recently used. 3 also, 0, 0. So out of all this, 2 is the one which is least recently used, so I'll replace here 2 with 4, it's a pace fault. Then 2 again, 4 least recently used will be 3, correct? So I'll replace 3 with 2, 0, 4, it is a pace fault. Again 3 has come, Okay, so unfortunately again I have to replace two most recently used 4 then 0. Okay, I'll replace here this one, it's a paste fault. 0, again I have to replace 3 most recently used 2 then 4, so I'll replace 4, it is a paste fault. Replace 4 with 0, 2 and 3. 3 is there in the main memory, I'll not replace anything, there is no paste fault. 2 is also there in the main memory, again no, again 1. Okay, again I will have a paste fault, I'll replace which one, 2 just now use, 3 also use 0. Okay, I'll replace 0, 3, 2. Again 2 is there in the main memory, so I'll not replace anything, then 0, correct. So again 2, 2, 1, so 3 is that paste which is least recently used, I'll replace now 3, 1, it's a paste fault, don't forget to mark this paste fault. Okay, then 1, 1 is there in the main memory, there is no paste fault. 7 is not there in the main memory, now which one I'll replace, in this direction if I see 1 is there, then 0, then 2, so 2 is the one which is least recently used, so I'll give here 2, it's a paste fault. Then 0, the CPU requests the paste 0 is there in the main memory, there is no paste fault. Then 1, it's also there in the main memory, there is no paste fault. So how many paste faults are there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here the number of paste fault has increased so much tremendously from 8 in the frame number 4 to 12 when the number of frames are 3. So when the number of frames we are decreasing, the number of paste faults are increasing. Okay, but shall we try the second example as well? Okay, so in the second example, let me have the number of frames 4 here. This is the first example that just now we have done. Okay, second example will be this one. Okay, let me just redraw it correctly. So here when the number of frames are 4, the request frame number 1, frame number 2, frame number 3, frame number 4. Okay, so the requests are 1, then 2, then 3, then 4, 1, 2, 5, 1, 2, 3, 4, 5. So here we are writing the request on the top of this table. Okay, for ease of use. So the first frame, it is a paste fault. Okay, 1. Second also it is a paste fault, 1, 2. Third is also a paste fault, 1, 2, 3. Fourth is also a paste fault, it is not there in the main memory, so this. Then the next request is 3, it is there in the main memory, there is no paste fault. Next request is 2, is there in the main memory, there is no paste fault. Then 5, so it's not there in the main memory, there will be a paste fault, but which one I'll replace? 2 just now I have used, 1 also used, 4 is 3 is the one which I have least recently used, so I'll replace 3 with 5, 1. Okay, then 1, it is there in the main memory, I'll not replace anything. Then 2, it is there in the main memory, I'll not replace anything. Then 3 again, so 3, 2 just now use, 1 also use, I'll not replace, 5 also use, again 2, again 1. 4 is the one which is not used in the recently, not used recently. Okay, so 3 I'll replace 5 2. This is a base fault. Then 4 again, the next request is 4, so 3 2 1. 5 is the one which is least recently used. Okay, so I'll replace here 5. So here this one will be 3 2 1. So it is a paste fault. Okay, then 5 again. So unfortunately we just have replaced 5, but again the next request is 5. So I'll replace which one? 4 no, 3 no, 2 no, 1. 1 is the least recently used paste in this main memory, so also it will be a paste fault. So how many paste faults are there? Let me count here. 1 2 3 4 5 6 7 8. So total number of paste faults are 8. Okay, we'll see when the number of frames are 3, then what will happen. Okay, so let me try to draw here only, accommodate all the frames here only if possible. I'll see. Frame number 1, this one. Frame number 2, let me change the ink color. Frame number 1, this is frame number 2, frame number 3. Okay, so the requests are 1 is there, then 2, then 3, then 4, fine. The next request is 1, then 2, then 5, after that 1 2 3 4 5, in this order, right? If I am not wrong, let me verify. 1 2 3 4, then 1 to 5, 1 to 5, then 1 2 3 4 5. Okay, so again we will restart. This time the number of frames, as you can see, it is 3. Okay, for the second question I am counting the paste fault. Okay, so the first is it is a paste fault 1 2. Second one is also paste fault 1 2 3. It's a paste fault. Now 4, it's a paste fault. And which one I'll replace? Least recently used one. So that is least recently one used is the page number 1, whereas 3 is the most recently used, right? So I'll replace here 3, again 1. So again paste fault is there. Least recently used is 2, so I'll replace this paste. 3 4, again paste fault because the next request is 1. It's a paste fault. I'll replace which one? 3. Okay, I'll replace 3 with 2. 1 4 will be as it is. Next request is 5. It's a paste fault, it's not there, so which one I'll replace? 2 1 4. 4 is the least recently used. This one I'll replace. 1 2. Next is 1. It's there in the main memory, so I'll not replace anything. Next is 2. It's there in the main memory. I'll not replace anything. Next is 3. So I have to replace what? 5, which is least recently used. This is 3. It's a paste fault. 1 2. Okay, then 4. So least recently used is 1. I'll replace here 2 3. This is a paste fault. Then next is 5. It's not there in the main memory, so it is a paste fault. And 4 is recently used, 3 also recently used, 2 is the least recently used among these 3, so I'll replace here 2. How many paste fault this time? 1 2 3 4 5 6 7 8 9 10. Total 10 number of paste faults are there. Okay, so this is the another example that we have discussed for LRU. So this is then one more concept called thrashing is there. Okay, so what is thrashing? So thrashing is a condition or a situation when the system is spending a major portion of time servicing the paste faults. but the actual processing done is very negligible. Okay, so thrashing has an impact on the operating system execution performance. So thrashing is a situation where I am having too many page faults, as you can see in the previous example. When I have reduced the number of frames, frame number 4 to frame number 3, the number of page fault has increased, right? Similarly, in the other example also, whenever I have increased the number of frames, the number of page faults are increasing. Okay, so this is one situation where the number of page faults will increase when number of frames I am reducing. But there are other situations also where you can see when I have reduced the number of frames, the number of page faults are also reducing. Okay, that is called Bilardi's anomaly, where adding more number of frames, okay, is ultimately increasing the number of page faults. Okay, so we cannot say definitely that when if I increase the number of frames, my page fault will increase or it will decrease. Okay, in some of the cases my page fault will increase, whereas in this previous case, increasing the number of frames from 3 to 4 is increasing the page fault, is decreasing the page fault, sorry. That means when I am increasing the number of frames in the main memory, so I am increasing the size of the main memory, that means. Okay, so if I am increasing the size of the main memory, then the more number of pages should be there in the main memory, right? So my page fault should be less, but that is not the case. As you can see for this example, using FIFO for this particular reference string, increasing the number of frames is also increasing the number of page faults. Okay, so that there are some situations where this Bilardi's anomaly can be seen. This situation is called Bilardi's anomaly. Whereas tracing is what? Tracing is your maybe the number of frames are more or less, but there are lot of page faults are there. Okay, there are a lot of page faults. So this page fault, whenever a page fault will occur, okay, then what happens? Then the CPU it does not get its desired pages in the main memory, so it has to then again load those from the secondary memory to the main memory, right? So this loading the pages from the secondary memory to main memory, it takes time. Why? Because main memory is a memory where the operations are faster compared to the secondary memory. In secondary memory, the operations are much slower than main memory. So loading a page from secondary memory to main memory, again it takes time. Okay, so this time that it is taking, these are just overhead for the operating system. Operating system has to the goal is that it should be efficiently doing all the operations, also so efficiently doing with less number of time. Okay, but if doing that operation is taking less time, but the loading the pages from the secondary memory to main memory is taking more time, so I have this situation called thrashing. Okay, here I am spending my majority time only servicing the page fault. What is servicing the page fault? I am loading the pages from the secondary memory to main memory. Okay, so this is taking more time than doing the actual operation. The pages that I am loading, it will do some kind of operation, maybe addition, subtraction, multiplication, maybe very big algorithms it is executing. Okay, but that execution of the algorithm is not taking that much amount of time, but loading the pages from secondary memory to main memory is taking more time. Okay, so this is not expected. Okay, it will slow down the entire execution of the, even if a particular programmer has written very efficient some algorithm for some particular operation or for some task, but if only page fault is taking more and more time, then it is not expected. Okay, So that particular condition is termed as thrashing. As you can see here in this diagram, you see generally the CPU's goal is what? It will increase the degree of multiprogramming. Okay, it will always why page faults also occur? Because in the main memory I am having pages for different processes. Okay, so at a time when for a particular page for particular process I am loading the pages. Why? Because the main memory is already occupied with other process pages. Okay, and why I do that? Because I always try to increase the degree of multiprogramming. But when I am increasing the degree of multiprogramming, the pages that is there in the main memory will be from different processes. Okay, so that's why CPU utilization, when the degree of multiprogramming is increased, the CPU utilization is also increased. In the very beginning, as you can see, when I need to utilize the CPU for some, suppose there is a process which is having CPU execution plus IO execution, okay, and then again maybe CPU execution. Okay, this is the order in which this particular process, suppose process 1, it needs to execute the operation. So first it will be using the CPU, so CPU will be utilized, no problem. But there is some time for which that process has gone for IO. Okay, so this time will be ideal time for the CPU, and to maximize the CPU utilization I will bring another process P2 during that time. Okay, I will give P2 that CPU when P1 was doing its IO, and then again when P1 is done with the IO I will again bring P1. Okay, now here I am utilizing the CPU more because now the degree of multiprogramming is 2. But here the problem is that when I am loading this particular page to the CPU, meaning is that I am loading these page to from the secondary memory to the main memory, correct? I am loading it to the main memory. So my main memory will be occupied with all the pages from process 2. Now when P1 is ready after the IO for execution, my main memory is limited, so I have to again unload the pages from P2 and load all the P1 pages again to the main memory. Okay, so when for the second this third slot of the time CPU will request the pages from the P1, those will not be there in the main memory. So there will be what? There will be page faults. There will be page faults, right? So again the P1 pages has to be loaded into the main memory. Now this loading and unloading, if it is happening more and more, that means when the number of page faults will be more and more, then even though we are trying to maximize the CPU utilization by increasing the degree of multiprogramming, after a point of time there will be some optimal point of time. After a point of time the CPU utilization will be less, in the sense that the actual operation that the P1 why I am doing P1, the operation that the algorithm that I want to execute, it will take time, but it will take less time than this loading and unloading to main memory. Okay, loading and unloading also takes time, right? So again there is possibility that the CPU utilization will be degraded. Okay, so after a point of time I cannot increase the degree of multiprogramming. Even if I increase, my CPU utilization will be less due to all the page faults that will occur, and the operating system will be more busy servicing all those page faults. Okay, so this situation is called thrashing. Okay, so that's all.